So, Geogebra again. This is the fifth one, I think. And this one I want to do some differentiation, I think. And we can do a fair bit of differentiation with Geogebra, but what I want to do with this one really is to just show you a couple of functions, and we'll do a little bit of integration, I think, as well. So if we have y is equal to, I don't know, 3 lots of x minus 2, and we're going to square that one, and then we're going to times that by 2x plus 1. Then we've got cubic, look. And then we're going to, no, I don't want a 2x in there. Right, that's, I don't want that 3. Let's just have 2. Don't want it to be too stretchy. Okay, and we'll have, let's make that a 3. And let's make this a minus, let's have that as a plus 4. There you go. Still very stretchy, so I don't want that 2 in there. Still really stretchy, but hey, we'll live with that. There's my cubic, and when I press enter, it will come up, and we'll see that it's labelled it as F, and I can display the equation in a few different ways, probably. No, it won't let me do that. So that's how I input it, and that's how it's sticking there. Let's choose a point on the curve, call it A, and we'll move A around a little bit. We'll zoom into that part, and if we put the function in our input bar of tangent, point and conic, point and function. Okay, so point is the point A that we just did, and if I right arrow and the function is called f, Geogebra labeled that function and they called it f, and what I've got is the equation of my tangent to the curve at A, and as I move A around, so I'm moving the tangent to my curve around 2. Isn't that good? I could also do tangent a point function, point. So the x value. So if I want the tangent of the curve at x equals 2 of my function, which I've just defined, we will see where that black line, I'm going to change it and make it a red one. Object color red. Get rid of it. So there's a red line. Where the red line crosses the green curve, touches the green curve, then we'll have a point of intersection. Red and green is that B, look, and the x value is 2 and the y value is 6. If I put 2 in here, I get minus 1, and square minus 1, I get 1, and then times by 2 plus 4 is 6, so 1 times 6 is 6, so when x is 2, y is 6, hooray! And there's the equation of my tangent, y equals minus 11x plus 28. Oh look, how many exam questions do you know where you've got to find the equation of the tangent? What about the normal? Well, if we do a perpendicular line for our point and the red line, so all I've done is select that one, click on my point first, click on my line second, because that's what it tells me to do, select point and then perpendicular line. That's the equation of my normal, and the equation of my normal, which is, so let's make that blue so it stands out, object properties, and we've got blue one. So blue line is the normal to the curve at B, and the equation of my blue one is this, so 11y equals plus x plus 64. And we could rearrange that. I think that'll let me equation y equals mx plus c, so y equals an 11th of x plus whatever that number was before, plus 5.82, which is the y-intercept. But we could change that back to have the form ax plus by is c, and we know that's very often the case of an exam question. Put your answer in the form of ax plus by plus c equals 0 or equals c. How's that? Yeah. So there's differentiation in a way, in a form. We found the tangent to the curve. We haven't differentiated our function, but we've found we should be able to differentiate our function with a pen and paper. and then put some values in and find the equations of tangents and normals, and then we can get Geogebra out and we can check our answers. Hooray! Let's turn those off. I don't really want to, yeah, we'll get rid of them. It's easier just to turn them off. What about integration? Well, let's have the integral from -4 to 3. So we're going to integrate. I wonder what the integrate. Oh, integral. Function variable. Function start value, end value. Right, there you go. Let's choose that one. Function is f. The start value is -4. And the end value is 3. And it shows us the area. And it gives us a value which sometimes is a little bit inaccurate. But if our answer when we do this with pen and paper is around 200, then we've got the correct answer. We're okay on Geogebra to 4 decimal places, but the way it works out, areas sometimes is ever so slightly off, but to 4 decimal places we should be spot on. I'd have expected this to be a round answer like 200, but maybe it's not. I'm not going to do the algebra while we're on here, the integration with a pen and paper to check it, and I'm just going to take the answers around 200. But we could do slightly more than that by putting a slider in. So if we have a slider A, and we can go from -4 to 0, and we're going to in increments of 0.5. I'm not going to bother to change the size of this. We have another slider, which they're going to call B probably, yeah, weirdly. And we're going to go from 0 until 3 with an increment again of 0.5, 0.5. Then I'm going to define 2 points, and if we put a coordinate in, it needs to be a capital letter. So I'm going to say that x1 is equal to, so point 1 is equal to a coordinate which is a, 0, and no, I'm going to have a straight line. I'm going to have a straight line, but that's how we would put a coordinate in. I'm going to just switch that off. x1 line is equal to a, and x2 line is equal to b, and for some reason they both come on and they haven't displayed them. So as I change that, why isn't it showing me the lines? Because I've got to put x in, haha. So let's get rid of them. Delete. Delete. So x is equal to a is a straight line, that one, and enter it, and x equals b is a straight line, and enter it. Let's have, should we have red and blue again? So red one, object properties red, object properties blue. I put my arrow on object properties blue for that one, and then get rid of it, save changes, and I'm going to integrate integral function start value end value. So function is f, start value is a, end value is b, and now we can integrate between some limits, and we can change our limits. We'll turn that previous integral off, and we can see that the area is this c value now, and as I change a and b by a half each time, so change a, change b, so I'm changing the area that's trapped between the x-axis, my curve, and the straight and the vertical lines, x equals -3 and x equals 1. The area is 165 and about a third probably, and between 3 and 1.5, 3 and 2, and so on. So we change the value of the area that we trap, and we get an idea of what integration does. A definite integral when we have limits between, in this case, -3 and 2, of this function gives us an area which is trapped by the x-axis, the line x equals -3 and x equals 2, and our curve, which is y equals x minus 3 all squared, bracket x plus 4. The area is approximately 178, and we should be able to work that out with a pen and paper. But we can check our answer using Geogebra nice and easily.